Now see this question. In this question, this circuit is given and these are three bulbs A, B and C connected parallel to this 12 volt supply source. So in this circuit, bulb A uses 36 watt, bulb B uses 24 watt, bulb C uses 14.4 watt. Now we have to find the additional A type bulbs in parallel to this circuit that would be required to blow the fuse of 20 ampere. Okay, so this is the fuse of 20 ampere and we have to find the number of additional this A type of bulbs that are connected parallel to this circuit so that this fuse of 20 ampere get blow off. See, for bulb A, we can write P is equals to V square by R. And here for bulb A, voltage is equals to 12 volt and power is given 36 watt. So we can write RA is equals to 12 square by 36. So that is equals to 4 ohm. Okay. Similarly, we can write RB, that is resistance of bulb B, is equals to 12 square because voltage is same across all three bulbs. So 12 square by what is power of bulb B? That is 24 watt. So that is equals to 6 ohm. And what is resistance of bulb C? That is equals to 12 square by 14.4, that is equals to 10 ohm. Now we know that current I is equals to V upon R. For bulb A, current IA is equals to V, voltage is 12 volt across this bulb A and resistance of this bulb is 4 ohm. So we can write V upon R, that is 12 upon resistance, that is 4 ohm, that is equals to 3 ampere. It means bulb A takes current 3 ampere and bulb B takes current that is equals to 12 by 6, that is equals to 2 ampere. Similarly, bulb C takes current 12 by 10, that is equals to 1.2 ampere. Now these are the currents taken by all three bulbs. Now we have to find the number of additional A type bulbs connected in parallel. Okay, so when we connect a single A type bulbs parallel to it, then it will take additional 3 ampere current. So in this way, suppose n number of A bulb connected. Okay, then total current here, suppose total current is IT. So IT is equals to, suppose current taken by bulb A is 3 ampere, bulb taken by current taken by bulb B is 2 ampere and current taken by bulb 3 is 1.2 ampere. If we connect n number of additional A bulbs, then each bulb will consume 3 ampere current. So total current consumed by n number of A bulbs connected in parallel is equals to n into 3. Now this total current must be less than equals to 20 ampere. Okay, so to find the limit, this current must be equals to 20 ampere. If the current exceeds 20 ampere, then this fuse get blow off. So limit is 20 ampere. So what is the value of n? 3n is equals to 20 minus 6.2. Okay, so we get n is equals to 13.8 by 3 and that is equals to 4.6. 4.6 means up to 4 bulbs this fuse will not blow off. If we add additional bulb, then the total current will exceed 20 ampere. So in this case fuse will blow off. So number of bulbs required, additional bulbs required to blow the fuse is 5. So we require 5 bulbs to blow this fuse. Now see this question that has been asked in GATE 2001. Here two bulbs of 40 watt and 60 watt are connected in series. Then which bulb will glow brighter? So we know that bulbs given with rated voltage, and here power 1, that is P1, is 40 watt. That is for bulb 1. And we know that P is equals to V square by R. And here R1 is the resistance of bulb 1. Similarly, we can write for bulb 2, P2 is equals to 60 by V square by R2. Okay. Now, when they are connected in series, then if these two bulbs are connected in series, then current through these both bulbs will be same, because they are in series, so current will be same. Now for the comparison, we will write the formula of power, that is P1 is equals to I square R1, and what is P2? That is equals to I square R2. Okay, and here we can see that this R1 is equals to V square by 40, and this R2 is equals to V square by 60. On comparing, we see that R1 is greater than R2. Okay, from this we can clearly say that R1 is greater than R2. So in this case, the power will be more in case of this R1, I square R1, because current is same. Now basis of comparison will remain, that is resistance. The bulb which has higher resistance will glow brighter because it has more power. So bulb 1, that is of 40 watt, will grow brighter. So 40 watt bulb will glow brighter because the resistance of this 40 watt bulb is greater than the resistance of this 60 watt bulb. Now see this question that has been asked in ES 2003 and ES 2016. Here bulb 1 and 2 rated for power P1 and P2. Okay, these two bulbs are connected in series, supplied with voltage V, and they are rated for power P1 and P2. Now we have to find total power supplied by the mains to two bulbs. Okay, so we have to find the total power supplied. We know that rating of bulb 1 is P1, that is equals to V square by R1. So from this we get R1 is equals to V square by P1. Similarly, we can write R2 is equals to V square by P2. Now when these two bulbs are connected in series, then how power is given? Total power P is equals to, here voltage applied is V square by Req, that is equivalent resistance. So what is equivalent resistance? That is equals to V square by R1 plus R2. And what is R1? R1 is equals to V square by P1. And what is R2? That is equals to V square by P2. So take V square common and cancel it. We get P1 P2 by P1 plus P2. So in this case, total power P is equals to P1 P2 by P1 plus P2. So this is the answer of this question. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.